So a ratio is the quotient of two quantities that have the same unit. And remember that the word quotient means division. So keep that in mind. Quotient means division. So we're going to go ahead and express these ratios here. So the ratio of 25 to 10, well, remember that quotient means division. So the ratio of 25 to 10 can be written as 25 divided by 10. And that's a fraction that can be reduced. It can be reduced by a factor of 5. So if I divide 5 out, the resulting ratio is 5 to 2. And that can be written as a fraction. It can also be written in this type of notation with the colon in between. Or it can be written in words as 5 to 2. So the fraction, the colon, and the word 2 are all okay. We had the ratio 0.3 to 1.2. Again, so that is a fraction, and we can, if you remember what we learned about decimals, to get rid of the decimals, we go ahead and we can multiply by 10 on the numerator and denominator, so this is equivalent to 3 divided by 12. And 3 divided by 12 can be reduced to 1/4. So the ratio of 0.3 to 1.2 is also a ratio of 1 to 4. Those are all equivalent ways of writing that ratio. The ratio of 32 to 16, again, that's a division, 32 divided by 16. They both have a factor of 16 in common, so we get 2 to 1 as the resulting ratio. Because the quantities compared in a ratio have to be of the same units, when we have something like 2 feet to 1 yard, we can't really write that as a ratio unless we write them using the exact same units. So for me to do that, I need to understand that 1 yard is equivalent to 3 feet. So in that scenario, 2 feet is to 3 feet. So that can be written like the fraction, or with the colon, or with the word 2. All of these are equivalent ways of writing it. Same thing when we're trying to compare 12 ounces to 1 pound. The 1 pound has to be converted to ounces, and 1 pound is 16 ounces. So when I do that, my ratio is actually 12 to 16, 12 ounces to 16 ounces. That will reduce, 12 to 16 reduces to 3 to 4. So that's one answer, or 3 to 4 written this way, or 3 to 4 written that way. And the rate, on the other hand, is a quotient of two quantities with different units. So in this case, in example 1, we have that the fastest growing flowering plant on record grew 12 feet in 14 days. What was the rate of growth in this period? So you can write this as 12 feet over 14 days. And just like ratios, that can be reduced. 12 over 14 reduces by a factor of 2. So we get 6 feet over 7 days is the rate. A total of 78 inches of snow fell in a 24-hour period. What was the rate of snowfall? So again, you can write that as 78 inches over 24 hours. Go ahead and reduce that if you want. That reduces by a factor of 6. We reduce that by a factor of 6, we get 13 inches reduced over 4 days. So the unit rate is 13 to 4. 13 inches to 4 days. A unit rate is very much like a rate, but it is a specific rate in which the denominator is 1. So in this example, first example here, we have that a driver makes a 354-mile trip from Orlando to Miami in 6 hours. What was the motorist's rate? So if we have 354 miles divided over 6 hours, we're just going to go ahead and set up the rate, and then we do the actual division to get the unit rate. So 654 divided by 6 comes out to be 118 miles per 1 hour. So this motorist was definitely speeding on his way to Miami. So example 2 says that Joan earns $436 per 40-hour work week. Managing a dress shop, find her hourly rate. So again, we set up the regular rate at $436 over a 40-hour period. Then we go ahead and do the actual division. When we do that division, we get that Joan makes $10.90 per 1 hour. So that's the unit rate, the fact that it's per 1 hour. In example 3, we have that a fast food restaurant sells a 12-ounce cola for 72 cents and a 16-ounce cola for 99 cents. They want to know the better buy. So we're going to set up two rates, and the unit rate is going to tell us which is the better deal. So 12 ounces for 72 cents versus 16 ounces for 99 cents. So let's go ahead and set up those rates and solve them. So when you take 12 divided by 72, you get that it costs 16, you get 16 points, about 16.6, 16.7 ounces for every cent that you spend. In the case of the 99 cents for 16 ounces, you do that long division, you get approximately 16.16 ounces per single cent. So the better deal would be the 12 ounces of cola for 72 cents because you get almost 7 ounces for every cent. And then the last example, we have that to heat a house for 30 days, a furnace burned 39 therms of natural gas. Find the rate of gas consumption of therms per day. Because we want to know per day here, we want day to be the denominator. We want day to be the 1. So we're going to set this up as such. We're going to go ahead and set this up as 69 therms of heat over a 30-day period. And again, the reason the days goes in the bottom is because we want to know the unit rate per day. When you take 69 divided by 30, we get that we consume gas at a rate of 2.3 therms per single day.